Welcome to Optical Communication course. We will learn here a fiber to fiber joint. So while installing a system or a network, so we need to know about how we can join a fiber there. Means we will connect a fiber, one fiber to another fiber without losing a power. Means we can say that low loss connection between the fiber is to be takes place there. Now where this fiber to fiber joint or a connection is required, that connection required from source to fiber, from fiber to fiber in between the link, and then at the end fiber to the detector. So we require a one specific connector to connect a fiber or to connect a source or a detector. Now then, how we say that a fiber, all the power emitted from the one fiber, or that modes were coupled from one fiber to the another fiber. So for that purpose we should know that fiber to fiber coupling efficiency. So this is about a fiber to fiber coupling efficiency. So this will tell you what are the various common modes that is propagating through the fiber, and what will be the number of modes emitting from the fiber. Now emitting modes means what, from one fiber, and whichever the common mode will propagating through the particular fiber. So number of modes common to this two fiber, so that will gives us the what will be the efficiency, fiber to fiber coupling efficiency. Now then we say that when we connect a two fiber, we require some particular connection or a joint, and that joint between these two fiber may be a permanent. Okay, so there that is called as a permanent joint or a permanent bond, or two fiber can be easily demountable. So means we permanently connect two fiber, or we can easily separate a two fiber by using the connector there. And that bonding this permanent, okay, connecting this two fiber or bonding between these two fiber, and that is called as a splicing. And if that is about a permanent bond or a permanent connection here, means at that particular place we are using a splicing technique, burn this particular place so that it will be connected. That is called as a splicing technique. And connector means what? We have one particular separate connector is there, or that particular groove. We have just we need to insert a two fiber end and then tightly insert here. There should not be any gap there. That is called as a connector. That is a demountable connector. So we can remove your fiber from that. Now that is a technique to connect a fiber. But in this both the technique, so what will be the coupling efficiency that we need to be learned. So then how your modes are connecting. Okay, we say that this is about efficiencies depending upon that what are the number of modes, and that number of modes we say for the two given particular fiber is depending upon, or that particular number of modes are depending upon the characteristics of fiber. So now what are the ways to connect a two fiber? So we should know that the fiber we are using, two fibers we are using, they have the same core size. If there is a same core size means what? That is number of modes propagating through the fiber will be the same. Or we say that another way we can say that a geometrical configurations are same. What are the geometrical configurations of this particular fiber? That is about the size of the fiber. When we use a connector, then we need to know about the what will be the geometrical characteristics of this particular fiber. Because number of modes will tell you what will be the fiber, geometrical configuration will tell you the size and everything. And then again, whether it will be a step index or a graded index, that we should know. If it is a step index and a graded index fiber, two different fiber, then we are not able to connect a two fiber. Or a mode distribution is what? That fiber core, so all the modes are equally excited. Means we can say that for a given particular fiber, this one is about your a core of a fiber. So in this given particular core region of a fiber, all the modes are fully excited in this given region. And some particular fiber they have a partially filled or partially propagating modes to the given particular fiber. Even if this one is belongs to the core, okay, this one is about a core here. But here we have these are the propagating modes. These are the propagating modes. Now these are the partially filled fiber core, and this one is nothing but a fully filled fiber core. So if you draw a diagram of a distributions of mode, so this one is about a core here. So in this particular case, this one is about a fiber core and it is a fully filled. And in this particular case, this one is about a core of a fiber, but instead of that, it is just like a partially filled fiber core. So that's why we should know that for a given particular fiber, if it is partially filled or full, fully filled here, in that case, the numerical aperture of a given particular fiber will be different. So that's why we should know that what will be the state of numerical aperture equilibrium for a given particular mode or at specific modes there. So that is about a modes when we propagating. Then another thing is what? A mechanical misalignment. That is about another portion of the fiber to fiber joint. We need to learn about that mechanical misalignment. Because when we consider these two particular fiber are connecting, so then what will be the size of this particular fiber? Size means what? That is the diameter of a core. If it is a step index fiber or a gradient index fiber. So in that case, we consider that what will be the size of that particular fiber, or we can say that the thickness of the fiber. Okay, we say that the thickness of the fiber. Then the given particular fiber will propagate a signal through this or the operation of this particular fiber, whether it will be a single mode or double mode or multi mode. That is operation of a given particular fiber. So these all these parameters are depending upon that what will be the core size of the given particular fiber. So then we should know that for a given particular fiber, how we are connecting the fiber, the way to connect it to a particular fiber with a all the power is to be coupled. If two fibers are not able to join properly, then there may be a radiation loss, and that radiation loss is due to the mechanical misalignment. So mechanical misalignment means what? For a given particular same fiber with the same core size, so it's about one fiber we say, okay, another fiber here we say. Right now, if we say that this one is about a two fiber. Now the core size of the two fiber thickness, everything is same now. Now what do you mean by mechanical misalignment? So we should know that for a given particular core, when we connecting these two fiber, that axis is to be matched. So that is called as we can say that lateral misalignment. Here we can say that one fiber is connecting to the another fiber. So this one is called as a lateral misalignment because there is a separation of a T factor. Two fibers are not the same. Likewise, there is small gap. Likewise, okay. So that's why we can say that is about a lateral misalignment here. The axis is not matched. Then again another misalignment. We say that there will be a separation between the fiber on this particular gap, or we can say that separation, and that is called as a longitudinal misalignment. Another misalignment is what? When we have the two fiber and in between the two fiber there will be a angular separation or a angular. Now these are about this different types of misalignment, and then because of this we are not able to connect or not able to join the two fiber. So here the axis is changed, and means we can say that if we have a given particular fiber and if you are joining the fiber another fiber because axis is not matched, so this may uses the axial displacement. Now this one is about a common area. This one a common core area by this two particular fiber. So now this one is the common area. If supposed to be these two fibers are matched, so then common area will be the same. So to calculate that how much is the misalignment, we should know that what will be the common area between these two fiber, what will be the separation between these two fiber, what will be the angular separation between these two, and then we calculate that how much will be the radiation loss because of this misalignment in the given optical fiber. So that loss we say is not only the two fiber have the same core size and all, or we can say that there is a mechanical misalignment. In addition to this alignment, there are some differences in the geometrical and waveguide characteristics of this particular two fiber. Even if it is a same fiber, we say that core size and everything is same. But there may be a small difference in the characteristics of this two particular fiber. And that may be include in the variation in the core diameter. Okay, variation in this particular core diameter, small variation is there. Or that core area instead of circular, there will be a elliptical ellipticity is there. Likewise, core diameter will be ellipticity. Or there may be a variation in this two particular fiber when we are joining. There is a difference in the numerical aperture of this two particular fiber. There is a variation in the refractive index profile, or there may be a variation in the core and cladding concentricity in each particular fiber. So that is nothing but a joining the fiber, but they have the fiber related losses that is to be considered, and then we can use or we can connect this. But all these losses occur, all these particular characteristics we say occurs at the time of manufacturing. So means manufacturing variations or some variation at the refractive index profile or this particular core ellipticity, there may be variation occurs because of that we are not able to connect the two fiber there. And again, when we are connecting the two fiber, so we need to prepare the proper end of the fiber. Just like we say that these two fiber we are connecting. So then when we are connecting these two fiber, so in this case we need to connect two fiber with their end. So fiber end phase preparation necessary. So means that phase of the given particular fiber, just like we say that this is about the one end of a fiber, and here is the another end of a fiber. Now consider that both the core and cladding everything is same now, constant. Okay. Now next portion. Next portion is about that whatever the end of the fiber is there, one end of this fiber, another end of this particular fiber. That is both the end when we connecting these two fiber, that there both the end is to be what you can say smooth there. If that faces are smooth, if these faces are smooth, then we are able to connect it to fiber properly. If the face is not smooth, if it is a rough, or while cutting the fiber, okay, we are just cutting in that way, this way, we are expecting that it is to be cut likewise, vertical one, but there is a small portion cut here. So when we cut that way, so in that case, it will not be a shape, circular shape. That end will not be a circular. That shape will be a likewise. Shape will be a different. Okay, that end will be a different. It will not be a circular shape. We are expecting that it is to be a circular in a shape, but at the end we are getting likewise or some likewise shape. Okay, that is about the end. So surface is not smooth. So now how to make this particular surface smooth? So that is called as a fiber end space preparation. Because of this surface is not smooth, then when we are joining these two particular fiber, then light will be scattered because of the that is the surface is not smooth. So now how to prepare this end of the fiber smooth? So that will be nothing but we need to polish this particular surface and make it smooth, or we just cut a fiber so that it will be a will get that a smooth surface. So generally people are using conventional grinding and a polishing technique that will produce a smooth surface. What we can use grinding and polishing technique, or we can use a score blade or by cutting the two particular fiber end. But if supposed to be we put the fiber likewise and I just put the blade here, I cut the fiber. But because of that fiber had some particular tension, so I could not cut the two fiber clearly. So that's why we need to control that fracture procedure of the fiber. So we need to make a fiber to be put on some particular curved form. This is about a curved form. And then here we need to make a tension. This one we can say it is about a tension. And then after that, that blade is to be used. Apply the blade and cut the section of the fiber. So that we'll get that a smooth surface. So there are the various procedure to make this particular fiber is a smooth, because we need to make a tension here and then we apply the force to cut the there is nothing but a blade here. Okay, tension is to be applied there and at the same time just apply the blade and cut the particular fiber so that that sections will be cut properly there. And then we are able to connect the two fibers. Next about a fiber splicing technique. In a fiber splicing means it is a permanent splicing means what? It is about a permanent joint, permanent joint or a permanent bond, so that we can connect a two fiber permanent. Okay, likewise. So it is about a permanent joint there. And how these two fibers are permanently joined? and where this particular splice is required, that we need to know. Generally, splicings are required, joint are required if we have the long link. In that case, we need to connect it to particular fiber. So then, in that case, we require a splicing technique. And then, how to make this permanent joint? That permanent joint that can be made using the fusing technique, or we can say that a fusion splice, or we can use a V screw mechanical splice, or we can use elastic tube splice. This way we can connect. Now, in the case of a fusion splicing, so we have this two particular fiber. This one is about a two particular fibers are there, and we require some particular connector to connect the fiber there. Likewise, we require a connector to connect or to hold this particular fiber end here. Likewise, just okay, hold this particular fiber here, another here to hold the fiber. Okay, holding this particular fiber here, and then apply the electric arc at this particular. Okay, so that it get heated. Okay, this one get, this should not be okay, gap should not be there. Okay, it is to be closer. Just I am showing that there are the two different fibers, so that's why I made here a gap. Okay, but this is not a gap. We need to make it closer and then apply the electric arc or heat. Okay, this means applying the heat by using that electric arc heat. This end is to be heated. Then we can join because it is a nothing but a fiber material, is a plastic material or a glass material. So we can easily heat it these two particular ends. This one is about, you can say, electric arc or a welding technique. This is about a fusion technique, fusion splice technique. Means we are connecting it to fiber using the fusion technique. But when we are connecting these two particular fiber, we should know that the ends are very closer, and that ends to be a very smooth. And then we need to apply a sufficient arc. If we apply large electric heat, larger heat, then it will be molded there and we are not able to connect. Okay, okay, that will be, it will burn, and there is no use of this particular joining technique. So we need to apply only a sufficient heat, otherwise it will burn there. And then from this splicing technique, we should know that whether this particular fiber we are using or fiber connector we are using, fiber connecting we are using for what type of application, whether that fiber will be single mode or a multi mode. If it is a single mode with, because that core size is very small, then we need to apply that heat, sufficient heat, and then we can connect it to fiber. Another technique is about what, a V groove technique. In this V groove technique, here is about a V groove type here, and in this particular V groove, we need to use the fiber. Okay, like that. And then we need to use a two fiber likewise. Okay, I actually this one. Okay, this one we grew here. We just connect the fiber likewise. Okay, and then we can connect. This is about a V groove splicing technique. So this one is about the end, and in that particular V-shaped groove, this one is about a V-shaped groove. So we are just connecting the fiber. V groove splicing. So this particular V groove is made up of what, a silicon or a plastic or a ceramic or any metallic substrate. According that that V groove is designed, and just we have to fit two particular fiber. Okay, just press that, and then the two fibers to be connected properly using this technique. Another one is about the elastic material, or you can say that elastic tube splicing. In this, the elastic material is to be used to connect the two fiber. You can say that we have the inserted fiber here. These are about the two fiber, and this material we can say that elastic material now. Okay, so means we need this one is about the elastic material. So here we see that axis is to be matched. A fiber inserted here and another fiber is to be inserted here. Okay, so this way we can make this one is about your axial alignment. So this elastic material automatically perform the lateral, longitudinal, and angular separation or angular alignment. So this type of a generally splice is to be used whenever we have only a single mode fiber. If it is a multi-mode fiber, so then there will be a more losses. Okay, in this particular type of a splicing. So mostly common technique people are using that is about a fusion technique, that is about a connecting the two fiber there. But in this case, we should know that what will be the size of this particular core and fiber there, that core diameter of the fiber. Then and then we can connect it. Okay, just like we need to insert it and we need to match this axis of this two particular fiber. That is about the we can consider a splicing technique. Next one is about a fiber connector. In the case of a fiber connector, we are just using, just like we have a pin and one. This one is about a connector. Okay, now it is closed now. So similarly, we have a fiber connector. It's one end of the fiber and another end of the fiber is to be connected. So that is a fiber connector, and that is a demountable joint. It is not a permanent one. So that connectors are required to connect a source to fiber. Then we can use this fiber to fiber, or we can say that fiber to detector. So just like we can consider a connector, or we can say that a coupler coupling the two fiber there. So we can consider this type of fiber. Some requirement for this particular good connector. So the requirements are what? That connector should have some requirements. It should have a low coupling loss. Low coupling loss means what? When we connect it to particular fiber, so in that case, that connector have the low loss. So that's why when we couple these two, so that loss should be low there. When we connect or when we disconnect, so that connector provides a low loss there. Then another is about what? Interchangeability. So means a two connectors, we say that they have the same standard. So if supposed to be one manufacturing design a connector for the fiber and another manufacturing design again the connector for the fiber. So that connector to be a compatible. Okay, so that's why that is about it. That connector must be compatible for one manufacturer to the another manufacturer. There. Another one is about a ease of assembly. This connector can be installed easily in any environmental condition or whichever the connector designed by the particular manufacturer that will provide a low loss and they can be used or they can be connecting easily there. Okay, and the same connector they have the low environmental sensitivity, low environmental sensitivity because any changes in the temperature or dust, moisture, they should not affect a sensitivity of this particular connector there. Okay, so means loss generally we say that it is depending upon the this particular factor, but they should not be affect the connector there. And then last we say that it has a low cost and a reliable there. Means that will be work for the long period or we can say that it will work for the longer duration there. That is about the reliability. Then that particular various connectors we can use and then there are the various diagrams of the connectors and that will be connecting a two particular fiber easily there. So some connectors are just we are using for joining the particular fiber or a fiber end there and then that particular end that will be used to couple the a power there. Okay, so that's why we need to know about that why this particular connector is used and where it is to be used there. Okay, that we need to be know there. So I'll just show examples of few connectors there and then how we are connecting the two fibers and all that I will show you. Okay, so wait. The one connector here this is about a ferrule connector structure of ferrule basic ferrule connector is there. Okay, sample this one is taken from maybe from that senior or case are there. Okay, I mean book, one of the book we have referred. So these are just like a, we have a cable that is about optical fiber cable here. Okay, and this one is a connector is used to join these two particular fiber. There is another way here that is connecting the two fiber, a multi-mode fiber here, multi-mode fiber connector. Okay, just like we have a ceramic capillary ferrule, then we have the alignment sleeve here, so that we just insert the two fiber here. Okay, using this connector there, locking out here. Okay, so this is about a threaded coupling hose. So just we can move here and we just connect, hold this two particular. This one is plug here. Okay, so it's about a connector, and this particular connectors to be used for connecting the fiber there. As I mentioned earlier, that is about a V groove type. It is like just like a V groove here. V groove splices. It's just like a material. Okay, that is a substrate we have. It's like a V groove type structure there. So these are about the connectors to be used to connect the fiber. Various connectors are there, and that particular connector they have the low loss, and that type of a connectors are